Hello everyone, welcome to today's session. My name is Zhihao Chen. I am a software engineer at Proxima Beta. Today I will be presenting on behalf of my team and sharing our practice of building event-driven system using Apache, Pulsar, and ScyllaDB. This system helps us monitoring and responding to a broad range of risks that occur in our games. Before diving in, we would like to thank event organizer and sponsor for giving us the opportunity to share our work. Before we move on to the agenda, please allow me to provide some background information about Level Infinite and Proxima Beta. Proxima Beta is part of Tencent Games. Now we are based in Singapore with other regional offices around the world. Our business is operating on live video games globally except for the mainland China market. Level Infinite is our brand for global publishing. You may have heard of our titles we are currently running, such as PUBG Mobile, Arena of Valor, and Tower of Fantasy. Our team at Proxima Beta is responsible for monitoring and responding to a broad range of risks that may occur in our games, such as cheating activities and harmful content. Let's move on to the agenda. Today's session had 3 parts. It's also a follow-up session of what we presented at the recent Pulsar Summit Asia. In the previous session, we discussed why we build our system based on CQRS and event sourcing patterns. If you haven't gotten a chance to go through the previous session, no worries. I will give you a quick recap of our service architecture to help you understand our system, how our system works before we dive into the main topic. You can also find out more information about the previous section by following this link. The first topic is how we use ScyllaDB as a distributed event store that functions like queue and is able to dispatch events to a large number of gameplay sections at the same time. The second topic is how we leverage ScyllaDB to improve our data governance. To be specific, making complex global data distribution problems easier to configure, test, and audit. Now let's begin the overview of our service architecture, which is based on CQRS and event sourcing pattern. If these terms are new to you, don't worry. By the end of this overview, you should have a solid understanding of this concept. The first concept I would like to introduce is event sourcing. The core idea behind event sourcing is that every change to a system state is captured in an event object, and these event objects are stored in the order in which they were applied to the system state. In other words, instead of just storing the current state, we use an append-only store to record the entire series of actions taken on the state. The concept is simple but powerful, as the events that represent every action are recorded so that any possible model describing the system can be built from the event. The next concept is CQRS, which stands for Command Query Responsibility Segregation. CQRS was coined by Greg Young over a decade ago and originated from the command and query separation principle. The fundamental idea is to create separate data model for reads and writes, rather than using the same module for both purposes. By following the CQRS pattern, every API should either be a command that performs the action or a query that returns data to the caller, but not both. They naturally divide the system into 2 parts, the write side and the read side. The separation offers several benefits. For example, we can scale write and read capacity independently for optimizing cost efficiency. From a teamwork perspective, different teams can create different views of the same data with fewer conflicts. The high-level workflow of the write side can be summarized as follows. Events that occur in numerous gameplay play sessions are fed into a limited numbers of event processors. The implementation is also straightforward, typically involving a message bus such as Pulsar, Kafka, or simpler queue system that acts as an event store. Events from clients are persisted in the event store by topic, and event processor consume event by subscribing to topic. If you are interested in why we chose Apache Pulsar over other systems, you can find more information in the link provided earlier. One thing worth mentioning is that why queue-like systems are usually efficient as handling traffic that follows in one direction. For example, fan-in, they may not be as effective at handling traffic that follow in the opposite direction, for example, fan-out. In our scenario, the number of gameplay sessions will be large, and a typical queue system don't fit in since we cannot afford to create a dedicated queue for every gameplay session. We need to find a practical way to distribute finding and metrics to individual gameplay sessions through query APIs. That's why we use ScyllaDB to build another queue-like event store, which is optimized for event fan-out. We will discuss this further in next session. Before we move on to the next section, let me summarize our service architecture. Starting from the right side, game servers keeps sending event to our system through command endpoints, and each event represents a certain kind of activity that occur in a gameplay section. Event processor produce finding or metrics against the event strings of each gameplay section and act as a bridge between two sides. On the read side, we have game servers or other clients keep polling metrics and findings through query endpoint and take further action if abnormal activities have been observed. Now let's move on the next section to see how we use ScyllaDB to solve the problem of dispatching events to numerous gameplay sections. By the way, if you search for ScyllaDB or Cassandra and queue using Google, you may come across an article from over a decade ago stating that using Cassandra as a queue is an anti-pattern. Why this may have been true at that time, I would argue that it's not. It's only partially true today. To support this dispatch of events to each gameplay session, we use the session ID as the partition key so that each gameplay session has its own partition, and events belonging to a particular gameplay session can be located by the section of section ID efficiently. Each event also has a unique event ID, which is a time UUID as the clustering key. Because records within the same partition are stored by the clustering key, the event ID can be used as the position ID in the queue. Finally, clients, ScyllaDB clients can efficiently retrieve newly arrived event by checking the event ID of the most recent event that have been received. There is one caveat to keep in mind when using the approach: the consistency problem. Retrieving new events by checking the most recent event ID rely on the assumption that no events with a smaller ID will be committed in the future. The assumption may not always hold. For example, if two nodes generate two event identifiers at the same time, an event with a smaller ID may be inserted later than an event with a larger ID. This problem, which I refer to as a phantom read, is similar to a phenomenon in the SQL world where repeating the same query can yield different results due to the uncommit change made by another transaction. However, the root cause of the problem in our case is different. It occurs when events are commit to ScyllaDB out of the order indicated by the event ID. There are several ways to address this issue. One solution is to maintain a cluster-wide state, which I call it pseudo now, based on the smallest value of the moving timestamp among all event processors. Each event processor should also ensure that all future events have an event ID greater than its current timestamp. Another important consideration is enabling time window compaction strategy, which eliminate the negative performance impact caused by tombstone. Accumulation of tombstone was a major issue that prevented the use of Cassandra as a queue before time window compaction strategy became available. That's all for this section. Now let's move on to the next section to see if any other advantage you can get other than using ScyllaDB as a dispatching queue. In this final section, we will discuss how we use key space and data replication to simplify our global data management. As we are building a multi-tenancy system to serve customers around the world, it's essential to ensure the customer configuration are consistent across clusters in different regions. Believe me, keeping a distributed system consistent is not a trivial task if you plan to do it all by yourself. We solve this problem by enabling data replication on a key space across all data centers. This means any change made in one data center will eventually propagate to others. Then ScyllaDB, also DynamoDB and Cassandra for the heavy living word that made this challenging problem seem trivial. You may be thinking that using any typical RDBMS could achieve the same result since most databases also support data replication. This is true if there is only one instance of the control plane running in a given region. In a typical primary replica architecture, only the primary node supports a read-write, while replica nodes are read-only. However, when you need to run multiple instances of the control plane across different regions, for example, every tenant has a control plane running in its home region, or even every region has a control plane running for local teams. It becomes much more difficult to implement this using typical primary replica architecture. If you have used AWS DynamoDB, you may be familiar with the feature called global data, which allow application to read and write locally and access the data globally. Enabling replication on key space provide a similar feature, but without vendor lock-in, you can easily extend global tables across a multi-cloud environment. The next use case we will discuss is how we use key space as data container to improve the transparency of global data distribution. Let's take a look at the diagram on the right hand of this slide. It shows a solution to the typical data distribution problem imposed by data protection laws. For example, suppose region A allows certain types of data to be processed outside of its border as long as an original copy is kept in its region. As a product owner, how can you ensure that all your application comply with this regulation? Our potential solution is to perform end-to-end tests to ensure that application correctly send the correct data to the correct region as expected. This approach requires application developers to take full responsibility to implementing data distribution correctly. However, as the number of application grows, it becomes impractical for each application to handle this problem individually, and end-to-end tasks also becomes increasingly expensive in terms of both time and money. Let's think twice about this problem. By enabling data replication on key space, we can divide the responsibility for correctly distributing data into two tasks. Number one, identifying data type and declaring their destination. Number two, copying or moving data to the expected location. By separating these two duties, we can abstract away complex configuration and regulations from applications. This is because the process of transferring data to another region is often the most complicated part to deal with, such as passing through network boundaries, correctly encrypting traffic, and handling interruptions. After separating these two duties, applications are only required to correctly perform the first step, which is much easier to verify through testing at earlier stage of the development cycle. Additionally, the correctness of configuration for data distribution becomes much easier to verify and audit. You can simply check the setting of key space to see where data is going. In summary, the key takeaway from today's session are: when using ScyllaDB to handle time series data, such as using it as an event dispatching queue, remember to use time window compaction strategy. Consider using key space as data container to separate the responsibility of data distribution. This may make complex data distribution problems much easier to manage. And if you have any question, please do not hesitate to reach us through the following links. Thank you all for your attention.